The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, or good evening. Welcome to our third week of this batch. All right, so we have Azhar, Kamesh, Karthik, Kuram, Mazir, Raj, Rangareddy, Sai, Shiva, Subhash, Subhajit, Venkat. I welcome you all, and hello once again. All right, so I guess you guys have gone through the concepts or revised them because we have covered our ELB and the auto scaling in our previous week. Also, we covered a couple of the topics like EC2, Elastic Network Interfaces, Elastic IP, and CLI. Today we'll just go further and we'll discuss our storage options that include the EBS and S3 and all those kind of things. But what I'm wondering is that before we can just move further and start discussing our storage options, it is quite important for us to discuss our VPC because we have discussed the EC2, Elastic IPs, and Elastic Network Interfaces. We can very well go ahead and start discussing our virtual private cloud or the VPC because it's quite important for us to understand that how to structure our own cloud or VPC, I would say that. Shiva is saying auto-scaling did not work, the instances shut down automatically and launch automatically. Shiva, if you are configuring everything properly, then the auto-scaling should work. And if the instances are shutting automatically and launch automatically, it means that you didn't launch any application on the instance. You didn't define any default web page properly. Consequently, what happens is if the application is not running properly on the instances, or the default web page is not being defined properly, the load balancer will fail the health check, or the Elastic load balancer will declare an instance as unhealthy. Thereafter, the auto scaling will terminate those instances and launch new one. Okay, so you have to be sure that you have launched the applications upon the instances, you have defined the default web page properly, and the configuration is proper. Okay. Somebody is saying I've tried but not be able to complete the communication between two instances locally with our IP addresses. Okay. All right. So today we're going to discuss the concept of VPC because what I'm wondering is that before we can start discussing our storage options, we should discuss the VPC first because it's quite important topic for us to understand because a lot many questions come from the VPC. Okay, so we'll discuss our VPC first, then we'll jump over to our storage and content delivery options. Now, till now, we have been using our default VPC to launch all our instances into. So now we're going to discuss that how to create, structure, design, or implement our own VPC from scratch. VPC means it stands for Virtual Private Cloud. And what are the things involved, or the components involved instructing our VPC from scratch. Raj is saying, I couldn't find the document in Google Drive. Raj, I'm not sure why, because other people are able to file the document, I guess. Previously, Ramakrishna was also facing the same trouble, and his issue was resolved automatically. So I don't have any clue that why you are unable to access the Google Drive or the documents to it, because other people are able to. Okay. So let's discuss our VPC essentials or the basic concepts of VPC. Now, what's a virtual private cloud? A VPC allows you to launch the AWS resources, into a virtual network. Now, this virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using scalable infrastructure of Amazon Web Services. So VPC allows you to create a virtual network. See, the thing is that the Amazon cloud is a public cloud. Why it's a public cloud? Because different individuals and organizations, they can come and they can launch their resources, their instances into that public cloud. Now, you don't have that much trust or confidence that, okay, if you're launching something into the public cloud, you don't have that much transparency into it as to how all the components are being adjoined, how the routing has been performed. So you don't have the visibility or the direct say that, okay, how these components are being adjoined at the back end, because this entire network that works at the back end, right, it is working in such a way that you can fit your resources into it. But how they fit and how the routing of the traffic has been performed, we don't have absolutely even a single clue that, okay, how it's working at the back end. As a solution or as a workaround, Amazon Web Services is saying that, okay, we give you some access and we give you something called VPC, or the virtual private cloud, through which you can have a direct access to the networking components. You can design your own network while having the transparency and the confidence, because it's been created, managed, structured, and owned by you. So you have this virtual data center deployed. It's a virtual data center or a piece of the public cloud that you carve out, and consequently you have the complete privilege to design, to structure, and to route the traffic between different components or the resources inside the same VPC. Right? Now you can think of a VPC as a virtual data center in the cloud. It's a kind of a virtual data center. You have the complete control. So with the virtual data center means that with VPC you have the complete control of your network. You create your own network onto the AWS cloud. So you have complete control because you define the IP addressing scheme. So the entire IP addressing. Now you will use the range of private IP addresses to formulate, to create or structure your entire design from scratch. So you apply the CIDR ranges or design, or I would say that you decide the CIDR blocks that would be, or the IP address blocks that would be assigned to your VPC, and also you assign the IP address ranges that you assign to the subnets. You define the subnets. Now subnets are of two types, public and private. So what is the difference between that? Public subnet means that this involves your public resources. This involves your public resources in which you can have your public instances running, which means that these resources that you are declaring as public, they are exposed to the internet, or they are accessible across the internet. For example, your web servers, web applications hosted on your instances, they are being represented as the public resources that are represented or that are accessible across or over the internet. Now you have something called private subnet. Private subnet means that the resources are completely private and they are not exposed to the internet. They are not exposed to the internet, and the thing is that you keep them private. You keep them hidden from the eyes of your actual users. In the private subnet, in actuality, you will keep your database servers or DB instances, because you will never have your external users to access your database instances directly, because that is not required at all. Why? Because your users would interact with your public resources, whereas the private resources you want to keep in your private subnet. So this helps you to segregate or create a different layer of your resources. Next, we have something called route tables or route tables. What are they? Route tables means that they help or facilitate the routing of the traffic between different components. The route tables, or through the route tables, you decide that how the traffic would be routed in and out from your VPC. For example, let's suppose that this is your VPC that you have created. Now, within the VPC, you have the instances running, and also you want that this VPC should interact with an external network called the internet, because internet is the biggest public cloud. You want that your private cloud, because this VPC is an isolated portion of the network. It's completely isolated unless you define a routing. So you define routing from your VPC towards the internet, but the routing is done through the route tables. So for example, you place something called IGW, or the internet gateway, at the border of your VPC, and through the route table you create a route. You give an exit point from the internet that reaches your internet, and so through the internet gateway you give an exit point to the route tables, and your VPC, that is an isolated portion of the cloud, can interact with all the users and the resources across the internet. In a nutshell, the route tables or the route tables help you to make the routing decisions effectively and efficiently. Apart from that, you define something called access control list. Access control lists are same as security groups. They are a list of firewall rules that you define. However, the difference is that this access control list helps you to filter the traffic towards your subnet, or for your subnets, I would say that. So what kind of traffic can reach or leave your entire subnet is being defined by the access control lists. Next, we have internet and virtual private gateways. What are they? These gateways they act as the exit points or the exit gateways for your VPC, right? Because a VPC is nothing but an isolated portion. Okay, because you structure your VPC around the private IP address ranges. So in order for your VPC to interact with external networks, you will have this internet and virtual private gateways defined. We'll discuss in detail why we need that. Okay. Now, these VPCs help you to define the public and the private subnets. Now, we'll just go to this diagram. So I will request you to pay the attention, because this diagram is an essence or the crux of your entire VPC. If you can understand the diagram, then it will be easier for you to grasp the concepts when we go forward and we start discussing how to structure or design our entire virtual private cloud. Now over here on the left side, where you can see, where you see the public subnet with the range 10.0.1.0.0, you can assume that this entire thing is a part of your VPC with the range 10.0.0.0/16. This is a range that you have assigned to your VPC. Now, what you have done is that you have created or carved out a public subnet in this VPC. Right? So what we have done so far is that in the public subnet, you have managed to keep your web servers. Web service means that they are hosting the web pages, and you want that these external users over here should be able to browse the web pages hosted on these web servers. Now, what you have done is that you have placed an internet gateway at the border of your subnet. This internet gateway gives your subnet access to the internet, or the machines in the subnet access to the internet. Whenever I assign the internet gateway to the subnet, it becomes a public subnet, right? It becomes a public subnet. So I assign this internet gateway to the subnet to make it public, so that the users can access your web servers across internet gateway, and also the web servers can respond to the user's query across the same gateway. So this internet gateway creates a gateway to the internet and helps the internet traffic to pass through to and fro between the users and the web servers. Now, apart from having this internet gateway allocated to my subnet, what I've done is that I've assigned the elastic IP, or I would say the public IP, to my web servers, right? So what's the relevance of the elastic IP or the public IP? The elastic IP on public IP is being required to make our instances exposed to the internet, right? Whenever we want to access our instances through the internet, either we allocate a public IP or we allocate an elastic IP. Public IPs are assigned automatically, whereas elastic IPs are completely managed by us, and it is being allocated manually to our instances. So these two prerequisites are quite important for us to understand. If we want to make our instances publicly accessible, there are two things that are required. First thing first, you have to assign either the elastic IP or the public IP to your instance. You can't skip that. This is your first precondition or the prerequisite that you have to fulfill. The second condition that you have to fulfill is that you have to assign the IGW or the internet gateway to the subnet. Fine. So you have to assign the elastic IP or the public IP to the instance. You have to assign the internet gateway to the subnet. If you don't follow any one of these two conditions, or if you skip any one of these two prerequisites, your web servers would not be accessible from the internet, or I would say you can't make them publicly accessible. Two conditions, I repeat, the two conditions that you have to follow to make your instances publicly accessible is that first thing first, you have to assign the EIP, the Elastic public IP, to your instance, and also you have to allocate the internet gateway to the subnet within which your instances are residing. If any one of these two conditions are not fulfilled, your web servers cannot be marked or declared as publicly accessible. So on the left side, where you can see the public subnet, both these two conditions have been fulfilled. Right. Now let's draw our attention to the right side, which means our private subnet with a range 10.0.2.0/24. Now, you assign the subnets to different availability zones. Might be this is assigned to availability zone AZ-A, this is assigned to AZ-B. That's a different story, because whenever you create or formulate the subnets, they should be assigned to different or same availability zones. Now, in the private subnet, the purpose of the private subnet, we have to understand this thing first. The purpose behind the private subnet means that you want to keep your database or backend application instances, and you want that these should be isolated and be hidden, because your user over here should interact with the web servers. He has no business that what's running at the backend. Yes, if this web servers need to fetch or write the data, this will work at the backend automatically. But this user over here has no say or no business that what's running at the backend. Therefore, I create or structure this private subnet to keep this portion completely isolated and hidden from my user's eye. To achieve this kind of isolation, what I've done is that I haven't assigned the Elastic IP or the public IP to any one of the instances running over here. You can see that these database servers or backend application instances, they don't have the public IP or the Elastic IP assigned. Also, I haven't assigned the IGW or the internet gateway allocated or assigned to the subnet over here. Consequently, this makes my private subnet completely isolated or secluded, because I haven't allocated both or any one of these two resources to my private subnet. Therefore, it's completely isolated, completely secluded. So in the private subnet, I should keep my database servers, database instances, backend application instances that should not interact with my users directly. Okay, so this is how you segregate or you create different layers of your resources inside your VPC. That's how you're going to create it. Now, apart from this public and the private subnet that we have discussed so far, you will see even more component over here. That is your NAT instance. Now, what's the purpose of the NAT instance? A NAT instance facilitates the secure access for the resources inside your private subnet. So what happens is that these are your database applications or database servers or database instances. Now, sometimes these database instances or DB instances need to access the internet to download some patches or perform some upgrades. For example, you have a MySQL engine of version 7.1. You want to upgrade it to 7.3 because this is the latest version of the MySQL engine that is available in the market. Now, in order to perform the upgradation or the maintenance or downloading of the patches, these database instances need access to the internet. Now, if you assign the elastic IP or the internet gateway, then you are somewhere define the purpose of having the VPC. Therefore, what you do is that instead of incorporating elastic IP or internet gateway, you create an internet NAT instance that you manage to allocate within the premises of the public subnet. Now, this NAT instance will have an elastic IP assigned as well. It will reside inside your public subnet. And what you will do is that, let's suppose that this is your internet cloud. This is your internet, right? Now, if any one of your database instances inside your private subnet need access to the internet to perform any one of the downloading operations, the traffic or the request will go through the NAT instance and will reach your internet. Now, the question may be asked, okay, the traffic is going through the NAT instance, but still, what we are achieving over here, what happens is, for example, if a person is sitting over here and he's trying to hack into your database servers to steal some data, what happens is that whenever the traffic flows through the NAT instance and reaches your internet, the NAT instance will reveal its own IP as a source IP. It will act as an imposter. It will say, hey, internet, I am making the request. Now, what happens is that I'm fooling this person over here, because instead of revealing the IP addresses of these database instances, the NAT instance is revealing its own IP as a source IP. So what I'm doing is that I'm hiding the actual private IP addresses of my database instances and allowing the NAT instance to reveal its own IP as a source IP. So this allows me to have a secure internet access through the NAT instance. NAT stands for Network Address Translation. So it will convert the IP addresses that have been assigned to these backend application instances to its own IP as a source IP. So through this procedure, I hide the actual private IP addresses of my database instances who are actually making the request. That's why we will incorporate or involve the NAT instance in our design to facilitate a secure internet access for our backend application instances residing inside our private subnet. So that's the whole story. Any questions or any doubts so far? Ramakrishna is saying that my voice is breaking. I'm not sure, guys, whether other people are facing the problem. Kamesh is saying, does NAT instance have elastic IP? Yes, Kamesh. NAT instance resides in the premises of your public subnet, and yes, it has the elastic IP. Guys are saying my voice is breaking. I'm not sure what's going on. Give me 1 second. Guys, I'm just switching my broadband connection. So let's see that if this solves the problem. So give me a few seconds. I may get disconnected for a while. So just bear with me. Alright guys, I'm back right now. So I switched the connections from one service provider to another one. So hopefully it should solve the problem if they're from my end. Okay. Kamesh, regarding the route table, we'll discuss in detail. Okay. I just gave a brief overview of all these terminologies. So once we go further, I will discuss in detail about the route tables. Okay. So guys, any questions, any doubts so far regarding this VPC? Anything you want to add? Anything you want to make it clear, because this is quite important. So in the public subnet, we'll keep the public resources. In the private subnet, we'll keep the private resources. So we align the internet gateway to the subnet to make it public. We have the elastic IPs or the public IPs assigned to the web servers. In the private subnet, both these two components are missing, which makes it isolated. And we have a NAT instance in between that resides in the public subnet. It has elastic IP, and the NAT instance facilitates a secure access for all the resources in the private subnet towards your internet. Okay. A combination NAT gateway and NAT instance are almost same. The thing is, NAT gateway, it is, I would say, NAT instance, it's a lines-based instance, whereas NAT gateway is treated as a separate device. But the functionality is the same. There's no difference. Shiva is saying, the internet gateway, is it associated with the subnet or VPC? Shiva, the thing is that the internet gateway is attached to the VPC, but it is associated to the subnets. Okay. So, Vidit, your question is, while creating the EC2, we haven't given any IGW, but we are able to access. So, Vidit, I'll discuss that point. Actually, the thing is that any of the instances that we are launching, we are doing so in our default VPC. Now, what happens in default VPC, that all the subnets have the internet gateway associated automatically. We'll discuss that why you are able to access your instances, because you already have the IGW provision for you. Okay, we'll discuss that. All right. Guys, do let me know if my voice still breaks. Okay. So let's move forward now. Now you can help, you can use your VPC to extend your corporate network. Now over here, if you can see on the left side, this is your entire AWS cloud. Right, this is your AWS cloud, and this contains your EC2 instances, right? On the right side, this is your own data center. Oh, this can be your office where your own hardware servers are being placed. Now what you can do is that you can adjoin these two networks. It's a kind of a hybrid model. Right? It's a kind of a hybrid model where you are extending your own data center onto the Amazon Web Services cloud. It's a kind of a hybrid model. So you are extending your data center network or your office or the corporate network onto the Amazon Web Services cloud. And these resources can be adjoined together using the BGP tunnel or the IPsec VPN tunnel, because this tunnel will be created through the internet. So you have this internet cloud in between, but you have a tunnel created so that the entire communication between these two networks, between your data center and the AWS, is being encrypted. That's why you have a tunnel created through the internet, so that the end-to-end communication between your machines on either side, whenever these machines communicate or send the traffic to and fro, the entire traffic or the communication gets encrypted. That's why you have these VPN tunnels created in between. VPN stands for Virtual Private Network. Kamesh is saying not able to hear me. I'm not sure, guys. Okay. So this kind of model, this kind of extension of your network gives you security, flexibility, and also it is cost effective. Raj, BGP is a protocol that we use in the networking. Okay. Now, what are the benefits that you get out of the VPC? You get the ability to launch your instances into a subnet. You have the ability to create or define the custom IP address range inside each subnet. You have the ability to configure the route or the route tables between different subnets. So what happens in this case is that these route or the route tables create the route between different components. You can facilitate the flow of the traffic within and outside your VPC. It gives you the ability to configure the internet gateways and attach them to the subnets. Internet gateways makes your subnets and the instances residing in the subnets publicly accessible or exposed to the internet. You have the ability to create a layered network of resources. So you can segregate your resources into the public and the private subnets. You get more fine-grained security settings to protect your cloud assets. So you have the security groups that you assign to the instance. You have the access control list that you assign to the subnet. And also you can extend your network onto the cloud using virtual private gateway through IPsec VPN tunnel. So we have seen in the previous diagram, we can have gateways assigned that can help us to extend our networks. See what happens is that we define our gateways in such a way that we place something called CG over here, that stands for customer gateway, and we place VPG, that stands for virtual private gateway, at our premises. So this tunnel is being created between these two gateways, because gateways help you, they act as an exit points so that two networks can be adjoined together. So you place the customer gateway in your premises, in your Amazon Web Services cloud. I'm sorry, it's the other way around. Sorry about that. So what you will do, you will place the customer gateway in your own premises, because as a customer, you have to place a Cisco router or a terminating gateway at the border of your network, whereas you deploy a VPG or the virtual private gateway at the border of your Amazon Web Services cloud, and you have this IPsec VPN tunnel created between these two gateways. So the customer gateway is placed at the border of your own network, whereas the VPG, the virtual private gateway, is placed at the border of your Amazon Web Services cloud, and you have an BGP tunnel running end-to-end between these two gateways. So that's how the communication happens. All right. Any questions regarding the basic concepts of VPC that we have discussed so far? The VPC essentials? No questions, no doubts? Now we're going to discuss the difference between the default and the non-default VPC. The reason being, the one that we are using till now is a default one. So right now, whenever we launch our instances, you will see that it automatically becomes publicly accessible. Why? Because it is being launched in a default VPC, right? So whenever we tend to launch an instance, so I'm going to launch an instance right now, right? And whenever I go to the config instance details, let me expand this. You can see that over here, it is saying VPC default, this one. So by default, whenever you launch your instances, they are being launched into the default VPC by default automatically, without even your notice. So the default VPC is the one that is being created by the Amazon Web Services. And also we have a second category that's called the non-default. Now this is the one that you create from scratch. Now we'll see the difference between the two. Default VPC. Now effective December 2013, the EC2 Classic is no longer supported. Right? See, what used to happen in the older Amazon Web Services account before December 2013, that there were two ways to structure your network. The first way was EC2 Classic. One second. The first way was EC2 Classic. So EC2 Classic means that you can launch your instances without or outside the VPC. This option was available before December 2013. So any kind of, if you come across any one of the accounts that was created before December 2013, you can very well see this option. Post December 2013 or post this month and year, this option cannot be seen in any one of the accounts because it's no longer supported. So using the EC2 Classic, you have the option to launch your instances or the resources without or outside the VPC. The second option that used to exist was the EC2 VPC. EC2 VPC, that which means that you have to launch your instances inside the VPC. You have to launch your instances inside the VPC. Now, after December 2013, what the Amazon Web Services is saying that we are, hang on one second. So what the Amazon Web Services is saying that we are phasing out this EC2 Classic. We don't support that. The only option that you're left with is the EC2 Classic. I'm sorry, EC2 VPC, which means no longer what's your preference is your instance should be running inside the VPC at any cost. Now they further segregated the EC2 VPC in two different parts. The first one is the default. It's called the default VPC, which means that's been created by the Amazon Web Services. It's like that, it's a cooked meal served on the plate and it's ready for you to be eaten. Everything is there prepared for you. You can launch your instances inside the default VPC without even designing it, without even knowing that how it's being structured. The second part of the VPC that's been created by you, it's called the non-default one. You are the creator, owner, and you have the complete transparency how it's been created. This is created by you, which means that after December 2013, it is mandatory for you to inside the instances inside the VPC or the virtual private cloud. Either you choose the default one or the non-default one. It's up to you. Default one is the one that's been created by default by the AWS Web Services. Once you sign up for the account, each region in your account will have a separate default VPC, whereas the non-default one has been created from scratch by you. So let's move further and see what are the other differences. I'm sorry. Oops. Hang on one second, please. So let's discuss that. What are the other? I think my screen got frozen. Okay, so we'll discuss that. What are the other things that are being available for us? First thing first, all new accounts have default VPC, which is mandatory for you to launch your instances into. You don't need to configure the VPC from scratch. The actual intention behind giving you the default VPC means that without having knowledge about it, because once you sign up for the account, it's quite obvious that you don't have any proper knowledge how to create your own design or design your own network. So Amazon Web Services say that till the point you know how to structure your own network, how to design your own network, we give you the default one, so that you don't have to create a VPC from scratch. All your instances will be launched within the default VPC by default. The default VPC has 3 subnets, 1 access control list, 1 security group, 1 internet gateway, 1 route table. Now there's a small correction over here. The correction is that it is not necessary that it should have 3 subnets. It can have 2 subnets depending upon how many availability zones you have. So in the default subnet, in the default VPC, if you have 2 availability zones, you will have 2 subnets. If you have 3 availability zones, you will have 3 subnets. So the number of subnets would equal to the number of availability zones. The rest options will remain as it is. Now, please pay attention. This is quite important. All subnets have the internet gateway attached to them automatically. In a default VPC, all the subnets will have the internet gateway associated or allocated automatically without even your knowledge. If I just go back and let me just go back to the main page of the console. If I scroll down, you can see under networking, this is a VPC, isolated cloud resources. I click on that. All right. So you can see over here, in my region of Northern California, I have this one VPC. Now this is a default one. I click on that. So this is my default VPC with this CIDR range. On the left side, I manage to go to subnets. Now these are the 2 subnets created within my default VPC, and these are the 2 ranges assigned to them. Just beneath my route tables, I have this internet gateway. This internet gateway, it's been assigned to the same default VPC that we are just looking into right now. Now, if I just go to the subnets back right now, and I choose any one of these two subnets. Let's choose our top subnet. I go to the route table. You can see over here it's saying destination 0.0.0.0.0.0/0, and the target is IGW6C46E309. This means that if any one of the resources inside the subnet need to access the internet, which means 0.0.0.0.0.0/0, which means any IP. If any one of the instances inside the subnet need access to any of the IPs across the internet, it should go through the IGW, which is my internet gateway. Let's choose our second subnet. The second subnet will have the same story. It will depict you the same configuration. For some reasons, this the magnet console is loading up slowly. That's right. Okay, so you will see the same configuration. Destination 0.0.0.0/0, and you can see the same target. So this means by default, all the subnets, by default, all the subnets inside your default VPC will have the internet gateway allocated or assigned. Plain and simple. Okay. Let's go back to our presentation. So all the subnets have the internet gateway attached to them automatically. We already discussed this point. I've already shown you this thing. And also, each EC2 instance has a private IP and an associated public IP address. So you might have seen this thing. As soon as you launch an instance inside the default VPC, now till this point of time, we're not discussing that what's the difference default, non-default, but you launch instances in the default VPC by default. And you've seen this thing that it gets the public IP automatically. Therefore, all the instances within your subnets, all these instances within all the subnets inside your default VPC will have access to the internet. So this answers the Subhajit's question that why our instances inside the default VPC are publicly accessible, because all the subnets have the internet gateway attached to them automatically, and each and every instance gets the public IP address automatically. Therefore, each and every instance inside your default VPC will have access to the internet by default. So that's why. That's the logic, that's the reason behind that. Now, if we discuss our non-default VPC, we also call it as a regular VPC. It's the same thing. It's quite opposite to the default one. This is the one that you create. All EC2 instances have the private IP addresses. No public IP or the elastic IP is assigned automatically. None of the subnets have the internet gateway attached to them. by default, none of the subnets have access to the internet. Your subnets, your instances inside the non-default VPC will never have access to the internet unless you make some necessary provisions from your end. You have to create everything from scratch, bit by bit, block by block, because the non-default VPC, the instances into that will never have access to the internet by default. You have an internet gateway that you have to attach to a subnet manually through an entry within the route table, right? So an internet gateway has to be attached manually. So in a non-default VPC, you have to provision everything from scratch, because in a non-default VPC, none of your instances will have access to the internet. So you have to allocate an internet gateway by yourself. You have to assign the elastic IPs by yourself. So everything would be done manually from scratch. Nothing will be given to you automatically. So it's the kind of thing that you have to create your own foundation. You have to create your own building upon your foundation. Everything has to be created from scratch. Today in the lab, we'll see how to create a non-default VPC. Because once you go into a real-time scenario, you should know how to do that. We have questions right now. Subhajit Singh, what about default route? Regarding the default route, Subhajit, the default route in your default VPC will have access to the internet. So the thing that I showed you, it's a default route, right? So let me show you right now. So this is the default route table I showed you. These are the default route table. For the non-default VPC, I have to create the route table from scratch. Okay, this is the default route table that is being associated to my default VPC. Okay. Let me just create the peering connections. Okay. Hang on one second, please. Okay. Kamesh, your question is, in a real scenario, we generally prefer non-default VPC or default. Kamesh, in the real-time scenario, you will structure or create your non-default VPC. You will never rely on the non-default one, on the default one. So non-default is a preferred. That's why this is an architect course. You should know how to architect, design, and create your own design. So once you go to the companies, they will expect you that you should build your own non-default VPCs, because default VPCs allow the internet access to all the resources by default, which is not a preferred option for the database instances. So non-default gets a high preference. Okay, guys, any questions, any doubts? I'm just pausing for a few seconds. Kamesh, your question is 172.31.0.0/16. What is 16 signifies? Subhash, /16 is a CIDR range. Okay. I'm gonna discuss that once we discuss the design. /16 is a CIDR block, which means we are taking the first 16 bits as the networking. Subhash is saying, does this course require what level of networking background? Subhash, just a basic one. So right now, these things we are doing, these are just the basic things. You don't have to go in depth. Okay. Any questions, any doubts? I'm just pausing for a few seconds. Kamesh is saying, can you show the route table entry for non-default? Of course, Kamesh. Once we actually will use a diagram to create our own network. So there I will show you how to create this non-default, because we have to create from scratch. Let me show you that. Yeah. So this is the what is it? This is the network diagram. We will be relying upon to create or structure our entire VPC. So in that we will see that how to create and modify our routes in the non-default VPC. We will discuss that. Okay. Akram, your question is, it's a good question you have asked. What about charges for non-default VPC and the unit to measure the cost? Akram, the VPC as a service is absolutely free. No charges for that. You can create, by default, you can create 5 VPCs per region, per account. You are not being charged or billed for the VPC that you create, but the resources that you run inside your VPC, including the instances, NAT instances, or internet gateways, you are being charged for that. Okay. All right, guys. So guys, once you, I guess we can take a small break of 15 minutes. Once you come back, well, we're gonna discuss how to design. So there are 14 steps involved. We have to pay the utmost attention and see those 14 steps involved, 13 to 14 steps, how to create our own VPC from scratch. And this is the network diagram that we will refer to. Okay, so let's take a break for 15 minutes. You just refresh yourself. Once you come back, then we're going to discuss all these concepts. We'll do the practical session. All right. So it's a break for 15 minutes. Thank you. Welcome back. I guess we are back now. So now we're going to discuss the concept of internet gateways, which will involve a brief concept on route tables. And once we discuss that, we're going to discuss our, or we'll just create the not default VPC from scratch. All right. So let's discuss the VPC or the internet gateway. Now, the simplest definition of the internet gateway is that it creates a gateway to the internet. In a default VPC, as we have seen so far, that we always have an internet gateway associated to it and attached to all its subnets. That's there by default. In a non-default VPC, an internet gateway has to be created and attached to any of its subnets manually. Now, you are allowed to create 5 internet gateways per region, which is equal to VPC limit. So you can have up to 5 VPCs per region and 5 internet gateways per region, which means that one internet gateway can be allocated to one VPC. That's it. Because one internet gateway solves the entire purpose. You don't need more than one internet gateway to be assigned to any one of the VPCs. Okay? So one internet gateway is more than sufficient, or sufficient enough to route your VPC's traffic across the internet. Okay. Now, what I would do is real quick is that I will just create a VPC. I'm not going to detail right now, but I will show you that how I have created an internet gateway, assign it to the VPC, and make use of route tables to align this internet gateway to any one of the subnets. Okay, it's a small, I would say, an example to show you. So I'm just creating a VPC real quick right now in front of you. I click on create VPC on the top, and I just name it as, let's suppose, test VPC. That's it. Test VPC, and I assign a CID range of 10.0.0.0/16. I keep the 10 as default and click on create. So I just created or managed to create a VPC with the range 10.0.0.0/16. Now, on the left side, I go to subnets and click on create subnet. This subnet will be created within the VPC that I just created. So I just name it as test subnet. It's called the test subnet, and I create that in the test VPC right now, and I will associate this test subnet with one of the availability zones, US West 1B, and assign a CID range of 10.0.1.0/24. That's it, and click on create. So if I just create a diagram right now, just to understand that what we have done or achieved so far. Okay, so what we have done is that we created this VPC called test VPC, right? Now in this test VPC, I just created a subnet called test subnet. Right. So within the test VPC, I just create a test subnet. I want that this VPC should interact with this cloud called internet. Right? So what I would do is I will attach a device, a virtual device that's called the IGW to the VPC. Now, once I've attached the IGW or the internet gateway to the VPC, how I gonna have this subnet or the instances in the subnet access this internet gateway? I will use something called root tables or route tables. A root table or route table, so that if the subnet wants to get access to the internet, it should go through the internet gateway. All right. So what I will do, I created the VPC. Thereafter, I just created the subnet. Now I will just create an internet gateway. I just go to the internet gateways on the left side, and I will click on create internet gateway. Now, this is the one that's been assigned to my default VPC. I click on create internet gateway on the top. You can see over here. Internet gateway is a virtual router that connects a VPC to the internet. Now, I'll just name it as test IGW, that stands for internet gateway, and click on yes, create. So as of now, what has happened so far, that has created the test internet gateway, but right now you can see it is in a detached state, which means that even if you have managed to create this component, it is not attached to any of the VPCs. So while it is being selected on the top, I click on attach to VPC and choose my non-default VPC, test VPC, and click on yes, attach. Which means that this internet gateway has been attached to my VPC. Now I want to associate to the subnet so that the instances inside my subnet, whenever they want to interact with any one of the IPs across the internet, the traffic should go through this test IGW. So I go to route tables right now and create a new route table. I just go to route tables on the left side. On the top, I click on create route or route table. And this is the non-default route table that I'm creating right now, which will be created by non-default VPC. You can see the definition over here. A route table or the route table specify how the packets are forwarded between the subnets within your VPC, the internet, and your VPN connection. Okay. So I would go ahead and just name it as test route table. I choose a VPC, that's a not default one, and click on yes, create. Right, this route table has been created. Okay, and once I create the route table, I click on edit. I click on add another route. I would say that if my destination is any IP 0.0.0.0/0, the target would be the IGW, the internet gateway. Hit save. Right? So once I add this route within the route table, I will associate this route table to my test subnet. I go to my subnets. this subnet will have a default route table. So I need to change it to the one that is created. I hit edit now and change it to the test route table and click on save. So this is how we align or allocate the internet gateway to the subnet through the route tables or the route tables, because the route tables make the decisions that how the packet will be forwarded within the instances inside a VPC, outside the VPC, internet, and so on. So I'm saying that any of the instances inside this test subnet in my test VPC, if it wants to access the internet, the destination would be this any IP, it will be through this internet gateway. All right. Any questions, any doubts? Kuram is saying, kindly update the practical lab, which component will be charged in VPC. Kuram, as emphasized before, the VPC is free, but the instances that you launch into it, the internet gateway and the virtual private gateways are being charged. So instances and the gateways are being charged. Otherwise, other components are absolutely free. Again, I repeat, the instances and the gateways are being charged. Otherwise, the entire VPC thing is free. Okay. Kamesh, you're saying, can we delete default route table as we have new? We can do that, Kamesh, but it's not required, because if you delete the default route tables and the default VPC, you can never get it back. Okay, it's up to you. You can delete that. So, Vijay, the question is, I can create multiple static routes as per my requirement. Yes, of course, absolutely. You can have multiple route tables depending upon how you want to design your entire network. There's no restrictions. I think you can create up to 200 route tables per VPC. That's a restriction. So I guess 200 route tables are more than enough. Okay. Any questions, any doubts? Before we can just move forward and start creating our non-default VPC from scratch. Anything you want to add? Anything you want me to repeat? Any concept? So, your question is it possible to transfer the instances between VPCs? No, not possible. But yes, you can create duplicate instances with duplicate volumes. That is possible. Shiva saying route table with subnet, can you repeat? Shiva, the route tables are associated to the subnet so that all the instances and the resources inside that subnet can get to know that, okay, how the traffic will be routed. For example, in this test subnet, which is a part of my VPC, if I assign this route table, I'm somehow inducing or instructing the subnet that if any one of your instances residing inside you wants to talk to this destination, that's the internet, that's any IP across the internet, then your target is this one. So a route table helps your resources to make the routing decisions. It facilitates the routing of the traffic within and outside the VPC. Kuram is saying, will we keep the bulk of IPs in this VPC for upcoming instances? Kuram, for any one of the regions, you just get 5 elastic IPs. So this thing you have to keep in mind. So in your real-time scenario, if you need more IPs, then you have to raise a request with the Amazon Web Services, because you never get the public IPs with the you don't get public IPs with the non-default VPCs, so you have to buy additional elastic IPs just in case if you need more. So this is about the public IPs. or the elastic IPs. Using the private IPs, regarding the private IPs, you'll use a private IP address range like 10.0, 170.0, 192.168.0. These kind of private IP address ranges you will use to create your VPC from scratch. Okay. All right. So let's do one thing. Are we going to go ahead and start creating our VPC from scratch? And this is the network that we will be referring to. Now I will explain to you the entire network from scratch so that based upon this network you can imagine that what we're going to build right now, right? Because as an architect, whether you're just creating a network or you're just creating a dam, a building, anything you are creating, you create a structure, a blueprint, right? This is a blueprint in front of us because based upon that, we will have these things in mind. Okay, this is how we have to structure or create or construct our entire VPC from scratch. Now to start with, on the left side, this is the entire VPC that we create with the range 10.0.0.0.0/16. Now if I'm saying 10.0.0.0/16, what do I mean by that? I mean that /16 means that first 16 bits. Now this is the, and these are the four. Give me 1 second. I'll just talk again. Hang on 1 second. Let me just 10.0.0.0. Let me just take another pen because this is creating some problem for me. Hang on 1 second, please. Let me just open the WordPad file. All right. Just give me 1 second. It's almost done. Okay. Hang on 1 second, please. Okay. So what I'm saying is that let's suppose today I decide to take this IP address range 10.0.0.0/16. Now, the IP address contains of 32 bits. So you have 10 as 8 bits, next 0 as another 8 bits, another 0 adds another 8 bits, another 0 as 8 bits. So 8 plus 8 plus 8 plus 8 plus 8, 32 bits. Right? An IPv4 address consists of 32 bits. Now if I say /16, this means that I'm taking the first 16 bits as my networking bits. And the next 16 bits would be, or the other bits that have been left out would be for hosting or host bits, right? Which means that I can create 256 subnets out of this one. How? It will start with 10.0.0 10.0/24, and it will go up to 10.0.254.255. Right. So what I'm trying to achieve over here is that I will create, for example, 1.0, 2.0, 3.0 up to 255.0, which means I can create up to 256 subnets out of this range that I'm displaying right now. Right? So now in the subnets, if I define, for example, the following range 10.0.1.0/24, which means the first 24 bits, 8 plus 8 plus 8, would be for networking, and the last one would be for the host. So my machines would be like 1.0, 2.0, 3.0 up to 255.0, which means in any one of the subnets I can have 256 machines running. So if I just perform the calculations over here, so in this VPC, with this range, I can have 256 subnets, and each subnet will have 256 IP addresses, so multiplied by 256. So I can have 65,526 elastic private IPs, which means I can have 65,526 instances running in this VPC. These are the maximum number of instances I can run in this virtual private cloud. Out of these private IP addresses, I will carve out someone for the internal communication, but I would somewhere have these many private IPs at my disposal to create or assign it to these many instances. Right? Now over here, what I've done is that I've carved out this VPC with the CIDR range, and these are the two subnets. So CIDR range of the VPC is 10.0.0.0.0/16, whereas the CIDR range assigned to the public subnet is 10.0.1.0/24, and the private subnet is 10.0.2.0/24. This subnet is assigned to availability zone A, whereas this one is assigned to availability zone B. Right? Now, what I've done is that in the public subnet, I've kept my web servers that are exposed to the internet, and I have attached the internet gateway to the VPC and somehow associated to the subnet through the root table. Now, whenever I attach the internet gateway to any one of the subnets, it automatically becomes my public subnet. So these web servers, they are receiving or sending the traffic through the internet gateway, right? And also I have the elastic IP assigned to the web servers or the instances inside my public subnet. Now if I move my focus towards my private subnet, you will see that I don't have the internet gateway associated to the subnet, nor I have the elastic IP assigned to any one of these instances over here, which means that this entire portion of my VPC that I just call it as a private subnet, it's completely isolated because I don't assign any one of these two components to this private subnet. Now, I have a NAT instance over here that resides in the premises of the public subnet, and it has the elastic IP assigned. The purpose of the NAT instance is so that the instances inside my private subnet can reach the internet through it. The NAT instance will reveal its own IP as a source IP, and it will hide the private IP addresses of these database instances that are in actuality making the request. So the NAT instance will facilitate a secure internet access for the instances running in the private subnet. So this is our entire design based upon which we will structure or create or construct our entire VPC from scratch. Any questions regarding this design right now? Anything you want to re-emphasize upon? Because now we're just going to go ahead and just start creating our steps for our VPC. I'm just pausing a few seconds. Let me know if you have questions. I think no questions right now. We can just move further and start creating this entire VPC based upon the diagram that is in front of us right now. Okay. So I will start jotting down the points one by one that we will just follow, because there are around 13 to 14 steps. So I'll start jotting down the steps one by one while I will apply those steps on the management console. So the first one is I'll create a VPC with CIDR 0.0.0/0 while keeping its tenancy as default. What do we mean by that? Let me just remove this VPC first, and then I'll just create from scratch. Whenever you delete the VPC, if you don't have instances running, it will delete everything. Subnet, security groups, access control list, everything. I click on delete. Okay, it's been deleted, and now we can create from scratch. So now I click on create VPC. You can see the definition of the VPC over here. A VPC is an isolated portion of the AWS cloud populated by the AWS objects such as Amazon EC2 instances. Okay, so now I will name it as my VPC, and I would assign a CIDR range of 10.0.0.0/16, and I would choose the tenancy as default or dedicated. Now this is quite important. What do we mean by that? What do we mean by dedicated or default tenancies? If you can recall, let me just open this. I'm just opening the EC2 dashboard so that we can recall that where we choose the tenancies. It's taking a while. I think I would remove the cache settings on my Safari browser because it's running a little bit slow. Just hang on one second, I'm signing in. It's opening much faster. I think I need to remove the cache settings on my Safari. Okay, so what I'm saying is that I'm just going to the EC2 dashboard right now. Okay, I click on Launch Instance, choose the instance type, AMI, and everything. Now over here, I choose the tenancy as shared undedicated. What's the difference? A shared tenancy means that you are running your instance on a shared piece of hardware, whereas a dedicated tenancy means that you're running on a dedicated physical host, right? Now, the things change whenever we choose the tenancy at the VPC level. So I'm just opening the VPC right now. So let us work on the Google Chrome because on the Safari it's working a little bit slow. So whenever I go to the VPC, so at the instance level, I choose shared and dedicated. Now, if I just go to the VPC right now and click on your VPCs and create a new one from scratch. So when I choose default tenancy while creating the VPC, this means that any one of the instances that are launched in this VPC in the future going forward, I will have the privilege to switch between the shared or dedicated, which means once I choose the tenancy as default while creating this VPC, I will have full independence and the privilege to choose between different tenancies as a shared or dedicated while launching the instances inside the same VPC. However, if I choose the tenancy as dedicated while launching this creating this VPC, this means any one of the instances or all the instances that are launched in the VPC will automatically be termed as a dedicated instances. So even if I create this VPC with tenancies dedicated, while launching the instance, if I choose shared, even then it will be termed or assumed as a dedicated tenancy instance. You can't override this feature later on. So if you choose as dedicated, you have to stick to that. Each and every instance, even if you choose a shared one at the instance level, would be automatically assumed and override by this dedicated tenancy. So you have to be very careful while choosing the tenancy as dedicated, because once you do that, you cannot roll back to the default one. Each and every instance will be assumed and it will be taken as a dedicated instance only. But if you choose a default, you have the privilege to switch between these two tenancies upon your requirement. So I will stick to the default values and name it as my VPC, and the CRD range 10.0.0.0/16. So I suppose that this is clear that why we need to choose a tenancy as default or dedicated. What's the relevance of this tenancy with respect to the tenancy that we choose at the instance level? I go ahead and click on yes create. So now this creates my VPC. Now I need to create my two subnets. So what I will be doing, I will create two subnets, public and private, in this VPC. So I go back. On the left side, I go to subnets. As per this network diagram, my public subnet will have the range of 10.0.1.0/24, whereas the private subnet will have 10.0.2.0/24. And they will be assigned two different availability zones. I go back on the subnets and click on create subnet on the top. Over here in the name tag, I will name it as, so what is the saying? Kindly check the first statement. I think you're talking about this one. Create a VPC with CRD range. Okay, I'm sorry. Thanks for the 10.0.0.0/16. Sorry about that. Yeah, might be I was lost somewhere when I typed this thing out. So thanks for pointing it out. So you have to create a VPC with the CRD range 10.0.0.0/16 while keeping its tenancy as default. Okay. Now I'll just go back and create my public subnet. This public subnet will be created in my non-default VPC right now, and I will associate it to my US West 1 bay. And the CRD range would be 10.0.1.0/24. I hit yes create. So my public subnet has been created. I create another subnet by just clicking on create subnet on the top, and I will just name it as private subnet. I will manage to create that in the same non-default VPC, but this time I will choose a different availability zone, that is US West 1C, and the CRD range would be 10.0.2.0/24, and I click on yes create. So my two different subnets have been created. Right. Now the next step that I will do is I would be working for this internet gateway, because I will create a new one, attach to this VPC, and associate it to my subnet through the route table. So what I will do, I will create internet gateway. So it is in the short form, let's name it as IGW, and attach it to VPC. So I go back. On the left side, I click on Internet Gateways. I click on Create Internet Gateway on the top. I just name it as my IGW. I click on Yes, Create. Once it's been created, I can see that it is in detached mode. I click on Attach to VPC on the top. I choose this VPC, that not default one. Click on Yes, Attach. So my third step is being accomplished. I create and attach this internet gateway to my not default VPC. Now I will create a route table. So I will create a route table with a route towards the internet through IGW, that is the internet gateway. I will create a route table with the route towards the internet through the internet gateway. So I go to the route tables on the left side, click on create route table. Now these are the default ones. I guess this was created by when I just created my previous, okay, this dependency. So I create a new one, and I will just name it as public route table. Why? Because this route table would be assigned to my public subnet. So to differentiate, I will name it as public route table, and I choose my not default VPC and click on create. So this route table is being created from my non default VPC. Right. So now while selecting this route table, I go to its route. Now whenever you create any one of the route tables, whether it's a default one or non-default one, you will see one thing. The destination would be the CID range of the VPC, the target will be local. This is called the local route table. Local route table. What do you mean by that? Local route table means that it facilitates the free communication between all the instances regardless of the fact in which subnet they're launched into. All the instances within the same VPC, regardless of the fact in which subnet they're launched into, they can send or receive the traffic or any kind of traffic to each other, unless you create any kind of blockages or filtering using the security groups or the access control list. Okay. So what I will do is I'll go ahead and click on edit. I click on add another route. In the destination, let's type in 0.0.0.0/0. In the target, I will choose my IGW and click on save. And now I will go to the subnets, go to my public subnet, go to its route table, and change its default route table to the one that is created. This one. Side. So what I will do? You assigned this newly created route table to the subnet to make it a public subnet. So whenever you assign a route table containing an entry towards the internet gateway to any one of the subnets, In actuality, you're making it a public subnet. Now, in the real sense, this subnet has become my public subnet because now it has the route towards the internet gateway. Right? Now, I will just go ahead and start launching my instances in both the subnets. So I go to my EC2. Let me just go back. And let me just launch my Amazon Linux AMI. Okay, let me just do one thing. I will choose my Ubuntu server 14.404. Click on select. Yes, I want to go to the Ubuntu server. Next. Now I will launch my instance while choosing my, I think I have to go back. I go to the instance dashboard again. I click on launch instance. I choose the same AMI Ubuntu Server 14.04. I go with the T2 micro instance type, and I choose my non-default VPC and its public subnet. You can see it says 251 IP addresses available, which means I can launch 251 more instances inside the same subnet. Actually, it is 256, but one is being taken by me right now. So we should have in actuality 4, right? The 4 instances, 4 IP addresses have been taken by the Amazon Web Services for its internal routing to assign it to the internet gateway at the backend or other resources. So I can launch 254 more instances inside the same subnet. Click on storage, tag instance. I'll just name it as a public instance because it is being launched in my public subnet. I click on configure security group. I will create a new one. I'll just name it as VPC practical. And this, for example, I will just allow the SSH and the HTTP from all the sources, just for this example. That's it. Now go ahead and click on review and launch. Launch. I will choose my keep here. And the same way, I will launch another instance in the private subnet. Real quick. This time I'll just do the private subnet, add storage, tag instance. To differentiate, I'll just name it as private instance. Configure security group. I will choose the same security group. Review and launch. Launch. I choose the same keep here. It's been launched. So now I have one instance running in each of the subnet that I've created. So what I'll do is you'll launch. So you have to launch instances in both the subnets of a VPC. Right. Any questions, any doubts so far? So what we have done, we have created our VPC with the tenancy as default, created 2 different subnets. For the public subnet, we created an internet gateway, attached it to the VPC, associated to these public subnet through the route table, and then now I launch one instance in each of the subnets. Any questions, any doubts so far? Shiva is saying how many instances we can launch with the same key pair. Shiva, as per my perspective, there's no limitation. But the only thing is that the key pair, the instance should be in the same region where your key pair resides. Okay, so there's no limitation that how many instances you can launch with using the same key pair. But the only thing is that they should be in the same region. Okay. So, Subhajit, your question is, can we communicate between these two instances automatically? Of course, Subhajit. These two instances can communicate with each other automatically because of this default entry, this one. This default entry, whenever you create a route table from scratch or you have a default route table, it will allow the local access between all the instances regardless of the fact in which subnet they are launched. So both instances can communicate with each other. Unless if you perform some restrictions using the access control list or security groups. Okay. Now guys, I want to ask you one thing. This public instance is being launched in my public subnet, which has access to the internet. Now, can I perform the SSH session towards this public instance? Yes or no? If you have the answer, you have to give me the reason behind that. So my question to you is that this public instance is being launched into my public subnet, which has access to the internet. Can I initiate the SSH session across the internet? Is it possible? Yes or no? Subhajit and Kamesh saying yes. What's the reason? Subhajit is saying 22 port is opened. Okay. Secret group TCP. Okay. Kamesh is saying secret group. Okay. Rangared is saying yes. All right. Okay. Guys, any other thing? Kamesh is saying SSH we have to enable. All right. Any other inputs from other people? Should I be able to connect to this instance via the internet or across the internet? Now, if you can recall, what I suggested is that if you have to make your instance publicly accessible, you need two things. First thing first, you have to assign the IGW assigned to the subnet, and you have to have the public IP or the elastic IP assigned to the instance. You have fulfilled the first thing, but not the second. How you can perform the SSH? Because this is, you don't have, if you just keep a closer look, you don't have the public IP over here. You just have the private IP. Private IP is not being recognized from the internet perspective. How you can connect to it? It's isolated kind of private IP. Right now, this instance has private IP. There's no way you can use that to connect your instance across the internet. It's not possible, right? So again, I go back to the same concept. You have to assign the elastic IP. So on the left side, I go to elastic IPs. Click on allocate new address. Yes, allocate. Go to actions and associate it to my public instance running in the public subnet. So you have to allocate or associate an EIP to the instance in public subnet. Now you should be able to connect to this instance via this public IP. So I go back, open my terminal, and perform the SSH. SSH-I Linux ec2-kp.pem Ubuntu @ I copy and paste the elastic IP or the public IP, the same thing over here. It says, are you sure you want to continue connecting? I would say yes. Sorry. And after a few seconds, I should be able to connect across internet because I'm using internet as a medium to get access to the instance running inside this public subnet. Kamesh is saying it gets the default public IP as like a default VPC? No, Kamesh. We get the public IP only in the default VPCs. But in the non-default one, we have to use elastic IPs that needs to be associated manually. So the public IP is an asset of your default VPCs. It has nothing to do with the non-default one. Okay. So now I'm connected. Now, should I be able to download the patches from the internet? Of course, because I have the internet gateway allocated to the subnet within which this instance is residing. So let me run the command sudo apt get update. I'm sorry, I mistyped the command. Sudo apt get update. And now I'm able to download packages, which means that this entire traffic is going through the internet or being downloaded from the internet, which means that the deployment of my public instance is being successful. If I just ping something, ping google.com, so I'm able to ping, which means the traffic can move in and out from this instance residing inside my public subnet. Ping facebook.com. Sorry. Okay, so we are able to ping the websites across the internet. All right. So which means that my public subnet has been deployed successfully. Now I have another question for you guys. Can I perform the SSH from the public instance towards this private instance right now? Let me just create a diagram for you to make it more understandable. This is the VPC that we just created, right? This is our public subnet, and this is our private subnet. I have one Ubuntu instance running in the public and one Ubuntu instance running in the private. Now this is me. I have performed the SSH towards this Ubuntu instance right now. My question to you guys is, can I initiate the SSH session from the public instance towards the private instance? Is the SSH session possible? There's a big question mark. Yes or no? If yes or no, that's the answer, then how? Somebody is saying yes, it should. Kamesh is saying we have to check the inbound for the private subnet. Somebody, if you're saying yes, it should, then how? Azar is saying we need to have SSH keys for each instance. Azar, it's not about the SSH keys. I'm talking from the networking perspective. Yes, Shiva is saying because of the route table. Absolutely. See, the thing is, again I repeat, because of this deep route table, this one, this is called the local route table entry. This is there by default in each in and out route table that you create. This is the destination is your VPC, the target will be local. This is called the local route table. This allows the free communication between all the instances inside the VPC, regardless of the fact in which subnet they are launched into. So what you're saying, are they in the same region or route tables configured? Yeah, you can say that. But over here, the precise and the accurate answer is because of the local route table, each and every instance inside my VPC can interact with each other because they are a part of the same network. Plain and simple. That's the right answer. Now, what I will do is, so watch this. Sai is saying no because NAT instance facility is secure, private secure. Sai, we haven't included NAT instance right now. NAT instance is optional. NAT instance is not required in all the architectures. Okay. Kamit is saying, but if the private subnet does not accept the SSH as per the security group, Kamish, that's a different thing. That's a different thing. Unless, see, the thing is, security groups and the access controls is an exception over here. If you don't apply or if you don't manipulate the security groups or the access controllers, if you don't perform the filtering, unless you have applied some restrictions on the security groups and the access control list level, my question was that can these two instances talk to each other? Okay, because you don't apply the SSH restrictions from the private IP addresses, right? Now over here, what I'm going to do is I'm gonna open my terminal again, and let me just exit out. So let me just upload my key so that I can use the same key to initiate the public and the private instance. So SSH add -k Linux ec2-kp.pem. Okay, I need to go to the directory. Okay, now I will perform the SSH towards my public instance. So this is my elastic IP of my public instance. Okay, so I'm into my public instance. Now, from the public instance, I will initiate an SSH session towards the private instance. So SSH Ubuntu @ I'll go to my private instance and copy and paste its private IP. Enter. So now from the public instance, I got into my private instance successfully. You can see that, right? From the public instance, I initiated an SSH session. Why? Because the default route table entry allowed the access. Unless if I impose some restrictions on the access controls level or the security group, that's a different story. But the default entries will allow the free access or the communication between all the instances that are the part of the same VPC. Now, can I install the updates in this private instance as I did on the public instance? Yes or no? That's my question to you. No. Why? Because there's no provision for the access to the internet. If it is from the command sudo apt get update, the chances are it will just keep on connecting, but it will time out. It will not connect, right? It's not connected right now. Also, if I just ping google.com, so it will result to the packet loss. Why? Because I haven't made any necessary provisions for this instance to download the patches from the internet. You can see over here, 0 received, 100 packets lost. So now I need to add the NAT instance for the private instance. Okay. So what we have done so far is we logged in to the private instance through public instance using SSH. Right. Now I need to go ahead and apply or define some steps to create my NAT instance. Okay. Therefore, before I can apply the NAT, I can create the NAT instance, I will do one thing. I will create a security group for my NAT instance named as NAT S3. Now you have to create a specific security group for NAT instance. Why? Because your NAT instance will be exposed to the internet and you don't want to compromise on the security. Now how to NAT instance, a NAT security group. Let's suppose that you are the NAT security group. You are the NAT instance. We are the NAT instance and we are sitting over here. We are the NAT instance and we are sitting over here. What would be the incoming traffic for us? This one. The backend application servers would generate an incoming traffic for the NAT instance, which means any kind of HTTP or the HTTPS traffic, which means this compromise of your web traffic, should come from the range of your private subnet. This defines your incoming traffic. And the outbound traffic should go towards the internet. This is your outbound traffic, the direction where your outbound traffic will go to. That is 0.0.0.0/0. Based upon this traffic flow, you will define the security group settings for your NAT security group. So I go back to my VPC dashboard. On the left side, I click on security groups. On the top, I click on create security group. I'll name it as NAT S3. In the description, I'll just type in this security group is for NAT instance. I'm going to create that in my same VPC. And now, in the inbound rule, I will say that if you are receiving the HTTP traffic, it should come from 10.0.2.0/24, which means that the HTTP traffic should come from any one of the instances within this range that belongs to my private subnet. And the same applies to HTTP. For the outbound rules, I'm saying that the same HTTP would be forwarded to the destination 0.0.0.0/0. I add another rule, HTTPS to the same destination 0.0.0.0/0. Save. So that's how I have to define the security group for my NAT instance. I think I didn't save for the inbound. HTTP will come from 10.0.2.0/24. And the HTTPS will come from the same source, which means any one of the instances residing in the range of my private subnet. Right? So I think this is clear. Now I will go ahead and launch my NAT instance. I go to my EC2 Management Console, click on Launch Instance. Now for the NAT instance, you have to have a special kind of AMI. You will not choose any one of these public AMIs. Go to Community AMIs on the left side and just type in NAT. Press Enter. You can choose any one of these free NAT AMIs. I will choose the top one. Click on Select. Configure instance details, and you will launch this NAT instance inside the public subnet. I'll just name it as NAT instance. Click on Configure Security Group. I will choose the security group that is created beforehand. Review and launch. Launch. Choose the key pair and launch the instance. That's it. Your NAT instance is being created. Now, if you just check the diagram, you also have to assign an elastic IP to the NAT instance. So what I will do, I'll go back, go to the elastic IPs, click on Allocate New Address, and associate this elastic IP to my NAT instance. Done. Now I have to do two more settings. So what I've done is that I've allocate an EIP. So you have to do one more thing. You have to launch instance while applying the NAT S3, and now you have to allocate an elastic IP to the NAT instance. Now there's one more setting that you have to do. Two more settings, I would say. I go back to the instances. I choose my NAT instance. Go to Actions. Go to Networking. And I go to Change Source Destination Check. It says, are you sure you want to disable the source destination check for the instance with the following details? Click Yes, Disable. So what do you have to do? You have to disable the source destination check option. Now why you have disabled that? Because you want that this NAT instance should let the traffic from the private subnet to pass through automatically without any stoppage or any blockage. The NAT instance is supposed to let the traffic from the private subnet to pass through. That's why you have to disable that option. Again, I go to Actions, Networking, Change Source Destination Check, and you have to disable this. Now, the last step. I want the instances inside my private subnet to route the traffic to the internet through the NAT instance. Now, how am I going to induce that intelligence? Because these are dumb terminals. I would say that if you have to go to the internet, go to the NAT instance. How am I going to instruct them? I would use a route table to instruct all the instances or the other packets of the traffic generated from the private subnet, saying that if you want to get access to the internet, go to the NAT instance. That's your target. So I go back, go to my VPC dashboard. On the left side, I go to route tables, create a new one. I will name it as private. Route table. I managed to create that inside my non-default VPC. Click on Yes, Create. And now I hit Edit. I would say that if your destination is 0.0.0.0/0, the target would be not your internet gateway, your NAT instance. This one. Save. So what you have done is that you have created a route table with destination towards the internet through the NAT instance. And now you're gonna assign this route table to the private subnet. So I go back, go to the subnets, and now for the private subnet, I change its route table from the default to the one that is created, and save. So logically speaking, I have provisioned my private subnet in such a way that if any one of the instances inside it wants to have the reachability to the internet, it should go through the NAT instance. Now, previously I was able to download the patches on my private instance. Now we'll see, can I achieve that thing? This is my private instance right now. and I will see whether I can download the patches or not. Sudo apt get update. So logically speaking, this should be possible now, because now the traffic will flow securely through the NAT instance. Okay, it's successful, which means the NAT instance is doing its own work. All these patches have been downloaded to the NAT instance. Let me see if I can ping something. Ping facebook.com -c2. Okay, I think it will not ping. Yeah, it will not ping. Why? Because I have to allow the ICMP traffic and the outbound rules of the security group. But anyhow, I'm able to download the patches because I have to enable the ICMP traffic. But I'm able to download the patches, which means the traffic is going to the NAT instance. If I go to the NAT security group and I go to the outbound rules and I allow the ICMP traffic, that allows the ping traffic to go through to anywhere, then it should allow the ping messages to go. Okay, I'm sorry. I haven't changed the settings on the security group for the instance as well, because this thing is being done to the instance, private instance, not this one. Hang on 1 second. So okay, it is allowing the outbound traffic right now. Hang on 1 second. Hang google.com. Give me 1 second. I think I need to change the inbound traffic for inbound rules ICMP all. In the inbound rules, I will also have to allow all the traffic ICMP. Save. I think it's working now. Ping google.com -c2. Okay, it's working because I haven't allowed the ICMP traffic. So I can ping the sites, I can download the patches on my private instance. It's been successful now. This entire traffic is going through the NAT instance. This creates or marks the creation of my entire VPC. These are the 14 steps. So this is how we have applied this entire diagram. Yeah, Shiva, your question is why we disable the option? Because we disable the chain source distance check because we want the NAT instance to let the traffic of the private instance to pass through. Yeah, so we do have I open the ping the ICMP traffic. Kamish is saying where we have to enable the private subnet or NAT. Kamish, we already we have done that in this last 4 or 5 steps. Okay. So what do you think? Is there any specification or for NAT instance or any specific OS? So it can be either your Windows based or Linux based. There's no specification. Okay. Kamesh, I have enabled the ICMP both at the inbound and the outbound in for my NAT security group. Okay, because my ping messages were not going through, so I've allowed the inbound and the outbound traffic in my NAT security group. This one, all SCP traffic from this private IP address range and the outbound to all the destinations. Okay. So we did this thing before assigning the NAT instance, how the DNS resolution was possible for a private instance. DNS resolution, I didn't see that. So in actuality, I'm not sure how the DNS is working at the back end. So they have some DNS or TCP option sets working at the back end that is resolving the DNS. She was saying you went the private instance to the public instance, and then you were able to get into, you would go to the internet. Yes, Shiva. So I logged into the private instance to the public instance, and now on the private instance, I was able to download the patches. Shiva was saying, can I go to the private IP address and connect to the instance? No, not possible. You can't connect to the private instance through the internet because your private instance would not be recognizable. Okay, so you have to log into the public instance first, and then from there you have to initiate an SSL session towards your private instance. All right. So guys, this completes our designing and the configuration of the non-default VPC. We are left with few more concepts. We're going to discuss it tomorrow. That like VPC peering, access control list, and VPC limits. So three more topics. They're small one that we're going to discuss tomorrow. Any questions, any doubts before we can just wind up? I'm dragging and dropping a document for you. It is quite important. That is this entire document contains the step-by-step instructions with a diagram that how to create a VPC from scratch. Okay. And also, I will also drag and drop this network diagram. This one. Okay. So just give me a few seconds over here. Okay, today's session 5. So in your session 5 folder, I am copying and pasting these two documents. This is an entire lengthy document that contains your entire steps that I've shown you, all the steps with screenshots, okay, and the diagram. So after a few seconds, it will get uploaded and it will show up from your side, okay. So what's saying, do we need to add ICMP in both the inbound and outbound rules for private subnet? I would say yes, Subhash. You have to do that for the private subnet as well. Security group. Yeah, it's necessary. Kamesh, you want the link? Hang on 1 second. Guys, I would highly encourage you to practice a lot because this is one of the most important topics. I'm just copying and pasting this link for you so that you can access this folder. So this is the link. Let's copy it. And so just copying and pasting the link for you again. That's it. So you can access the documents that I've saved for you today. It will take some time to replicate, and then you can do the practice on your own. Raj is saying I'm not able to see the documents. Raj, I'm not sure what's the problem is because other people are able to access it. So I would say that try some other browser and see that if you are able to see the documents. So I will send you a new link, Raj. You can just see that if you can access the same. Or let me do one thing. You're given your email address. Let me do one thing. But it will also, hang on one second. If I add your email address, give me 1 second. So I'm adding your email address, Raj, over here. So you should be able to access it. All right. Kamesh is saying it's not showing up for you 1 and 2. Kamesh, just let me know your email address. Raj, please check up now and see if you're able to access it. Kamesh, just give me your email address. Okay, hang on 1 second. I'm just adding your email ID in the list. Share. So I'm adding Kamesh email ID as well. Okay, guys, if any of you guys, oh, I'm sorry. Okay, so you're at, I think you're at it now. Okay, Kamesh, you're also at it. So Raj, you can see them? Great. So Raj, are you able to see session 1, 2, 3, 4, and 5? And same goes to Kamesh as well. Rangareddy, I'm just adding you as well because if not able to see all the documents, I think this workaround will work. So I'm sharing it with you as well, Rangareddy. Okay. Done. So Rangareddy, you can also see that. Okay, it's some other email. Somebody is saying second document for the 5th session. Which second document are you talking about, Subhajit? So it's the diagram and the document that contains all the steps. So I'm not sure which one you're not able to see. So Subhajit. So Rangareddy, I've just added you for the second email. Yeah, so for 5th session, there are two documents. One is a network diagram, and one is the document with all the steps. All right. So that's it, guys. Thank you so much for your time and patience today. We'll meet tomorrow. We'll continue with our conversation. We'll just keep on running through all these interesting topics. Okay. Tomorrow we'll cover a few concepts that we left with the VPC, a few with the Route 53. And we'll see that what things we can do. But tomorrow, so the agenda for tomorrow is we'll cover a few concepts that we left with VPC, Route 53, and if the time permits, I'll cover the IAM. All right. Thank you so much for your time and patience. Last but not the least, it's my humble request. If you found today's session helpful, then please fill the feedback form after this session gets over. It's just a matter of 30 seconds or 1 minute. That's it. You have to rate the instructor, that's me, the content, and you have to put your comments. So it's my humble request, please fill in the feedback form because I have to show that to the higher management. All right. Shiva is saying auto scanning, can we put the CURL link in which we have the PDF? Of course, I will do that, Shiva. For 1 second. Auto scanning. So I think you're referring to, I'm not sure which link you're talking about, but I think you're talking about this load balancer link. So I'm copying and pasting this thing in the folder. Okay. So I'm going to copy this code and script. Let's copy this one. I go back to my 30th July folder, and in the session 3 and 4, I'm pasting the script. Script is already there, Shiva. In which we put in advanced setting when we launch configure. Shiva, I didn't get your point. Bin bash, it's already there, Shiva. It's already there, I think. This is the one that you have to use. It's already there. Yeah, Karthik, after some time you may be able to see 5 as well. Otherwise, you give me your email address, I will add you. Of course, Shiva, it will work. I've tried and tested from my side. It will work for you. Yes, of course, Shiva, that will work for you. Karthik, you just give me your email address so that I can add you. Kamesh is saying, explain the document. Can you put for reference? Kamesh, that has been mentioned in the document as well. But as for the copying and pasting, you can use this one. Yeah, thanks, Shiva. Karthik, I'm just waiting for the email address from your side. Just do that real quick. Guys, please don't miss tomorrow's session, because tomorrow's session we have to cover more important topics. So, okay, Karthik, I just got your email. Hang on 1 second, please. So, Karthik, I'm just adding you in the list over here so that you can also access. Okay, I think you didn't. Give me 1 second. It's Karthik.Venkatraman. Okay, let's copy this one. Okay, so Karthik, I was added you. So you can also see the documents now. Give me 1 second. Okay. I'm not sure why I'm getting the error message while adding you. Okay, you've been added, Karthik. Yeah, Karthik, I've added a point instead of comma. That's okay. Yeah, thank you so much, guys. Good night or good morning, as per the time you're zoning right now. And last but not the least, please fill the feedback form. All right, please don't forget that. Goodbye. Bye-bye.